All right, let's do it. Sine, cosine, tangent. For number one, could I use my 30, 60, 90 rules? I could, because it's a 30, 60, 90 triangle. Let me tell you this little tidbit. You are not responsible for those rules. They will not be asked on the Regents exam. That is like an extra topic, all right, that I do here in honors, all right? It is not necessary that you know that, just like it's not necessary that you remember log sines and cosines. Can you use all that stuff? Yeah, it's still available to use, but it's not required that you know that. What is required is sine, cosine, tangent, though. That is required. So up here, we got to figure out which one of the three do I use, because unfortunately, that board's not going to be brought down to Gym B with me. All right, so we got to make sure we can spell SOHCAHTOA and know how to use it correctly. So if I'm going from the 30-degree angle, 9, what's the x in 24? X, opposite, adjacent, or hypotenuse? Adjacent. How about the 24? Hypotenuse. So if I have those two sides, which one of the three can I use? 18? Cosine. So I abbreviate that COS with the angle 30 equals adjacent x over hypotenuse 24. Remember how to solve these? I put cosine 30 over 1, and I cross them up. Okay, I cross them up. Cosine 30 times 24. Make sure we round to the nearest whole number here. 14. 21, thank you. Good job. Would I have still gotten 21 if I used my 30, 60, 90 or law of sines? Yeah, I would have. Okay, absolutely I would have, but it's not necessary. All right, next up, how do I find an angle? Same way, except when it's time to solve. Same way. We're going to find angle A. Somebody identify what the 9 and 14 are. 23, 9. Adjacent. How about the 14? Hypotenuse. I'm not going to ask anybody because we just used it. That's cosine. So cosine, you can put an X there. I'm going to put A for angle A. Adjacent side 9 over hypotenuse 14. All right, here's where it starts getting different. You don't cross multiply when you find an angle. Only a side. Even if you did cross multiply, you're going to get stuck real quick and not know what to do. You do not cross multiply when I find an angle, only a side. What do I do instead? Take a look at your calculator. Anybody remember where I go on the calc? Max? Inverse. So now I do angle A is going to be found by taking the inverse of cosine 9 over 14. That's how you find an angle. So how many degrees in angle A? 9? When you're ready.
50?
50, yep. So I should have choice 3 here. Now those are pretty easy problems. You'll see on tonight's assignment if you try it, you can use sine, cosine, tangent for more involved problems too. All right, I just don't want you guys to get the mindset, oh, that's going to be easy on it. You'll see tonight when you start some of the assignment. All right, also part of this, I think we did a day of this in the sine, cosine, tangent unit, is when are sine and cosine equal to each other? There's an instance you have to remember when sine and cosine are only equal to each other. So if I have cosine of angle A equal to the sine of angle B, this is true. Only, anybody remember? You have to know what, Will, about angle A and B.
If A and B are supplementary.
Oh.
Complementary.
Okay, complementary. What's that mean? They add to 90. Good. This up here is only true if angle A and angle B are complementary. Okay? I cannot set cosine and sine equal to each other unless those two angles are complementary. Now that I know that fact, that makes this problem pretty easy, right? X equals 90 minus 72, 18 degrees. Right? Only true. I can only set sine and cosine equal to each other if the angles add to 90. All right, different version of this fact right now, number 4. Right triangle ABC, right angle at C. Okay, just a quick visual here. If the right angle's at C, what do we know about A and B then? Those angles have to be what? They have to add to 90. Everyone agree? They have to, right? They have to add to 90, which means, all right, now look what I'm giving you. I'm giving you the sine of A and the cosine of B value. If A and B are already complementary, what do I know about those two values? If I already know A and B add to 90, what should I know about these two here? They don't add to 90. I want to make sure I'm clear. We're very clear here. I am not going to add those together and set them equal to 90. No, that the angles add to 90. Hey, what do you know about sine of A and cosine of B? What symbol am I going to put in between them? Not an addition equals 90. What am I going to put in between them? What do we know about them? They're equal to each other. So I'm going to take 2x plus 0.1 and set it equal to 4x minus 0.7 because those values are equal. Right? Because you knew A and B were already complementary. It's the angles that add to 90, not the sine and cosine values. The angles add to 90. And 0.4 here, x equals 0.4. Okay, so watch that. It's going to come up every year. All right, that they have to be, the angles have to add to 90. All right, everyone see at the bottom of their page, I got a little flow chart for you. Or not. About add a flow chart. There we go. Flow chart. This is in your cold hard facts packet, but I didn't want you to keep going back and forth between the two. So if you have to reference properties, here they are. And show you, you got to know some detail here. When's a parallelogram a rectangle? So I got to know my rectangle properties, detailed wise too, not just they have right angles. That doesn't matter here. When does a parallelogram become a rectangle? Look back at your flow chart. What's so special about a rectangle other than all the angles add to 90? Because that's not going to help me here. 11. Diagonals are congruent. So that's how it becomes a rectangle. Oh, I want to make sure we have a thorough review. Why am I not selecting diagonals or perpendicular? That would make it into a rhombus. All right. Why am I not selecting 3 and 4? Anybody know what those are properties for? Oh, yeah, square, but even less. Those are still parallelogram properties. That doesn't make it into a rectangle. It's still a parallelogram. Congruent diagonals make it into a rectangle. And I apologize for putting in 6. 6 is the same exact question as 5. Right? A parallelogram is always a rectangle if diagonals are congruent. Everything else here is either a rhombus or still a parallelogram. All right, let's go hardcore now. 7. And I'm telling you now, I don't want to hear because it looks like it. That's not why I'm going to be selecting an option here, because it looks like it. So which quadrilateral best classifies ABCD? Can we do process of elimination here instead of just circling the right answer? Which one can you definitely know it's not? Trapezoid, and that's not because it doesn't look like one. Opposite side, one pair are parallel, and I can definitely do slopes and show you both pair are parallel. Anything else you want to get rid of? Why a square? And don't tell me it doesn't look like it. Okay, how can you prove that to me? Because I'm going to be picky here. You find the slopes, and they won't be perpendicular to each other. So there goes square, and there would go what other figure too if they don't have right angles? Rectangle. So we can definitely confidently say it's a rhombus. The other way to go about it, hey, I want everyone to draw on both diagonals right now. Here's another way we can go about it if I definitely know my properties down pat. Can you guys count how long each is? Are they congruent? Are those diagonals congruent? So there goes square and rectangle because diagonals are congruent there. But they are what? Perpendicular. So that's why the rhombus is there. Okay, we can also do the diagonal. All right, buckle up. Your calculator is going to get some work now for number 8. Rhombus math. All right, so we're dealing with the rhombus. 0, -1 is M. And 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 is t. What's the equation of the other diagonal? All right, so MH represents a diagonal of this rhombus. I'm looking for the other equation of the other diagonal. To help me out visualize this, I'm just going to randomly put in AN, H where maybe they should be. So I can visually see this other diagonal. So I'm just going to say A, I'm just going to say H, not too sure if they're actually there, just so I can see the other diagonal. This works perfectly into what we talked about yesterday. If you're going to ask me to find the equation of the line, I'm going to ask you for two things. I need two things to write the equation of a line. One thing, 20, slope. Yep. So I'm going to have to find the slope of AH eventually. I need slope. And the other feature I need to write the equation of a line, slope and 4. Think about y equals mx plus b, Laisha. I need slope and what's the other part I always need to find?
The y-intercept.
Y-intercept. All right, so those are the two pieces I need. Help me find them. Let's start with slope. This is a rhombus. Those are diagonals. What do I know about the two? 20?
They're perpendicular.
Perpendicular, so they should have, from yesterday's discussion, negative reciprocals as their slope. All right, so can you first find the slope of MT, the one we're given? Oh, perfect time. Let's get it out. Formula sheet, let's get it out so we can write down the slope formula because we're about to use it. Woo. Let's go. Slope, y2 minus y1 over x2 minus x1, or in this case, because it's graph, you could also use rise over run. So let's get box 3 filled in. And go ahead. I'm going to need somebody's help finding the slope of MT right now. What is the slope of diagonal MT? You can use either the formula or rise over run. Count them up. Up and over. $11.
7/4.
7/4 for my slope. Yep. Let me just make sure I'm on the right page. 7/4. All right. What's going to be the slope of the other diagonal then? AH. That slope should be 23.
-4/7.
-4/7, the negative reciprocal. Good. We're good so far. Slope's done. How in the world do I find y-intercept? Well, if you were in class yesterday, we always find y-intercept by using y equals mx plus solve for b. But yesterday, I gave you a point the line went through, and that's what we plugged in for m and x. I don't have a point it goes through, or can I find one? Can I find a point that is on AH by knowing my properties of a rhombus again? Yes, the diagonals are perpendicular. What are they doing to each other? Bisecting, which means they intersect at each other's midpoint. Formula sheet, pack out. Let's go. Which one's this? Number 2? Yeah, midpoint. Anybody want to drop some serious knowledge here? Midpoint? Zip it. Laisha?
x2 plus x1 over 2 y2 plus y1 over 2.
Is that what you're going to say?
Yeah.
No, you weren't. Doubtful. All right, go ahead. Find the midpoint of MT because that'll be a point on AH. So find the midpoint of MT. Sorry, and I apologize. I should have apologized at the beginning for giving you 0 room to do all this in. All right, I'm over it. Midpoint of MT. And these numbers are not going to be pretty, so you're not doing something wrong here if you're going ahead of me here. These numbers are not pretty. How about that midpoint, huh? How about that midpoint? 18? 2.5. Good work. Now let's plug it in. Ready? 2.5 equals -4/7. times 2, the x coordinate, plus b. And yet, it's not going to be pretty. Go ahead and solve for b. Preferably as a fraction, please, because I don't think that decimal is going to be neat. I don't think, anyway. How's 51 over 14 looking? There it is. So the equation of the other diagonal, y equals negative 4/7 x plus 51 over 14. Come on. Whew. Again, old Regents question. Probably was like a part 3 question worth 4 points. All right, one more toughie, and then we should be on easy street, I think. Number 9. I'll give you 2 coordinates of a parallelogram. What statement makes it into a rhombus? Make sure the question is clear. We're not asking what fact is true there. We're asking what would make it into a rhombus. 0, 7, and 2, 1. If I connected those, what would it be of the parallelogram? That would be a what? It would be a not a side. It would be a diagonal, right? Because remember how I label it, clockwise or counterclockwise. So I would go A. Come on, don't do this. A, B, C, D. So AC would be a diagonal, and I want to make it into a rhombus. Looks like I'm dealing with diagonals of a rhombus. What do I know? What's the one big fact today? Diagonals of a rhombus are 21?
Perpendicular.
Perpendicular, so that would mean negative reciprocals for my slope. Do I care about midpoint? And look, it might have a midpoint of 1,4. I don't know, but I'm not looking for that's not going to make it into a rhombus because it has a midpoint of 1,4. Length of radical 40? Would that help it be a rhombus? No, remember, diagonals are perpendicular, not congruent. Ooh, BD having a slope of 1/3 or AB having a slope of 1/3? Well, I don't know. What's the slope of AC? We've been talking negative reciprocals. Let's find the slope of AC, and maybe I can answer that a little bit better between the two. Rise over run, y2 minus y1 over x2 minus x1. Anybody find the slope of AC here? Woo, 9. Find it?
Not yet.
All right, let me know.
-3.
Yep, -3. So negative reciprocal would be positive 1/3. So the other diagonal should have a slope of positive 1/3 to make it into a rhombus. Tricky. You and your group, number 10, if you haven't done it already. Look back at the flow chart if you need your parallelogram properties. I'm going to start you with angle R is 124, and I need you to get to angle AFD for me, using properties of a parallelogram and just heck, some geometry facts. Get there. Ooh.
Yeah, that's 68.
Know your quads. My first question, what else did you label? You labeled 124, which was given. What was your next move? Not your full move, just what was your next one? I don't need to know all of them. 28, where'd you go next?
FDE.
Yep, which is?
124.
Parallelogram implies opposite angles congruent. Where to next? 3?
FDA 56.
DA?
FDA.
FDA, there we go. 56. Linear pairs are supplementary. That was our second unit of the year. Linear pairs are supplementary. I should have put this on there, right? That was given right here. Now where? 3 again.
SAD 56.
In a triangle, congruent sides across from congruent angles, and then I'll finish it here. You should have ended up with 68 degrees. 180 minus those two. All right, so a lot of quadrilaterals. Now you're starting to realize I need to know eventually in 2 weeks, and by 3 weeks anyway, I need to know my properties. And then I just want to, oh, there we go. All right, here you go. I can be giving away something random in here. What's choices? What do we got?
Genie.
Slide left. Shatter.
Drop.
Swing.
Spin.
off the show.
I'll give you top 3 too. Ooh, and Promethean Man. All right, here you go. Top 3. Clock. Cube. Star. Fade. Curtain. Spin. Pinwheel. Genie. Swing. Shatter. Pinwheel. I had it on there twice. Slide right. Left. Book. Curl. Drop. Okay, so we'll take Genie. We'll take Pinwheel. Swing. Sure. Slide left. We'll take all of them. And Promethean Man. All right, got to go back a slide because obviously we're done. I don't even know what you guys picked, but Pinwheel, Genie, Swing, Slide left, and Promethean Man. Comes from the corner, going down. Wow, the Genie, finally.
What channel?
The block.
I'm just going to be empty in the store. We got, I'm not too sure, it looks like some winter themed peppermint patties, a coloring book. What we got more in here? We got some more candy, it looks like. Give away. There we go. More candy. Yeah, your own wrist.
Don't do that skill.
Here we go. Wow, look at this treasure load here. Huh?
You don't know.
Does this sound like ABC?
It's undisputed. It's
probably like ESPN HBO show or something.
We're watching. We're watching in the morning. It's like at 10. In the morning. It's at 10. Yeah,
Oh, I just
There's a missing brand. So there's a coloring
Yeah.
book. Yeah, I'll throw in 2. 1 for you and your friend. There we go. Sure. How about a junior class tie-dye T-shirt too?
You get the t-shirt.
I get t-shirt.
So, 3 by 3.
Here we go.
That might not-
How about that? And I'll throw in a box of delicate task wipers. All right, not too All right, there we go. Okay, here we go. Go up and claim your prize. 10. All yours, Jack. Congratulations. Congratulations. There we go. Okay, here we go. Let's finish this up. Let's finish this up.
I'll take some. Yeah, I'll take some. What do I do with it?
It's not my problem.
You should give.
Here we go. All right. Last topic here, very small topic. You'll probably only see it once on the test, but it does come up every year, and that is how many degrees do I have to rotate a regular figure to get it back to itself? All right, so for the first one, I have a regular pentagon, minimum number of degrees that carries it onto itself. Look, is 360 an option? It is, but it's not the minimum, though. There's something smaller than 360. And just so we're all clear here, a little visual representation. Here you go. Oh, I get that pentagon back. How many degrees did I just go? That's what we're looking for, all right? How many degrees minimum can you go so when you rotate it, you get that same pentagon back you started with? Easiest way to do it, hey, if I go all the way around, I go 360, and I know every time I do it, it's the same amount, same amount. How many rotations would it take me to go 360? Number of vertices, 5. So I take 360 divided by 5, 72 degrees. All right, a little more complicated version, number 9. What if I'm not looking for the minimum? You know, everyone does this problem. They're like, oh, I remember doing that one in class. I take 360. It's a decagon, 10 vertices. And they say, oh, answer's 36, but you don't see it listed. I'm not looking for the minimum. I'm looking for anything, any degree measure. All right, so you think, all right, 36 would do it. Do it again. Now you've gone 72 from the beginning. And everyone see I keep adding 36 until I find one that's listed. Which ends up being, yeah, you got to go deep here, adding 36 every time. Got to go deep. 252 degrees. All right. Questions, comments, any concerns? Remember your textbooks. You can start bringing them in. Go ahead, get going. We're not wasting any time here.
What?
You choose. You choose. Yes, I'll give it to you in a second.